This is a short introduction to what I call integrated documents. As an example, I'm using a paper on diagnostic plots, first presented at the Ravensburg meeting 1992 and later published in the Yellow Book. The paper originated as a loose-leaf collection used in consulting. It goes through the usual and some not so usual diagnostic plots. The common theme is, a diagnostic plot is only as good as the hard statistics that is supporting it. To take something simple, here's the empirical distribution function with the Kolmogorov-Smirnov statistics as a related functional. Now an experimentalist reading the paper will ask, how does the plot look like with my dataset? The data may be in some spreadsheet or jotted down with some word processor. In an integrated document, mark your dataset, drag it over to the document, and there you are. There's the plot showing your data. Or starting with the plot, you can ask for the underlying data. Well, you click on the plot to open it, and here are your data. Taking a selection of the data and dragging it to the plot will show you that subsample. Integrated document means statistics truly integrated in your documents. It also means integration of statistical documents in your workflow. If you want to use a plot in your context, you drag or copy it over to your document and edit it, as has been done here. For example, in teaching statistics, we have to explain that a plot shows just one sample, but what we have to study is the underlying distribution behavior. How does the plot look like if we take repeated samples? To illustrate this, here's a random number generator driven by a clock. Each second a new sample is drawn. Dragging it to a plot gives you a new sample shown at each tick. Actually, this is a real random clock. You can create new instances. Each instance will have its own random sample size and a distribution chosen at random from a small list of textbook distributions. What if you do not want to stick with textbook examples? In an integrated environment, you just draw your distribution using the mouse. Acceptance-rejection sampling gives you a sample of that distribution. Dragging it onto a plot links both. Now you are ready for entry-level experimental statistics. You can start asking questions like, what if I have a skewed distribution? Box and whisker will show that easily. How about flat parts in the distribution? What if the distribution is bimodal? Box and whisker does not pick it up, but then it was not designed for this. But the shorts plot does reveal it easily. Is this an accident? Using methods we have already seen, we can drag the clock to our distribution to link both. The clock pulse will tell our distribution to update, which gives you a new sample, and here we have a running simulation. Now we can do experiments in real time. You have seen the idea, you will know yourself how to make best use of it.